So you can see that we have an aircraft, basically an aircraft glider. In this scenario, what we are going to do is we are going to take in an enemy aircraft or competitor aircraft, see whether we can make something which is more agile than this. Simple terms, whether it can be controlled much easily or it can take more sharp turns, better turn radius and whatever. It's easy to control. So this is called cockpit, basically where pilot sits. This is called control surface, which help the aircraft to go up and down or either roll. This is most probably ailerons. So as basically ailerons help aircraft to tilt on axis like this. We have VTail design in this thing. We basically VTails enable you to aircraft to go up and go down, or just like this, your axis. And we have swept wing design. Basically wings swept forward. Generally speaking, in most of aircraft, the wings are swept rear. Yeah, no issue. Let's see what we can do. Let's create something. Um, Elevators, as I already told you, and rudder. That's basic thing. Hmm, it's nice. Seems good, basically. Uh, but I think the aircraft will have low agility because the control surface is way too big. The wings are very big and thin, and this is perfect aircraft for gliding as its role glider. And in this scenario, we will see whether we can make somewhat more agile glider. This looks very nice, very good. As you can see, the tail is shape of V shape like this, to symbol as it is. So basically, by having V tail, you can do ele- you can have two things at once: elevators and rudders. So if they both work together, it will work as elevator. If work at one time, it will act as rudder. Let's discuss our design. Hmm. So we are talking about fuselage. Hmm. Okay, so let's make some canards. Basically canards. Wait a minute, my drawing is not that good. I know, but this is right now a rough design. But a tail or vertical stabilizer, cockpit window. Not the best looking thing I know. Canards. So basically, what canard do is they are called second wing. Basically, they help you to generate additional lift as well as you can house elevators also there. Means the elevation thing. The last aircraft, the rear side detail was needed to build a aircraft up or aircraft down. In this, we have put up canards in the front of the aircraft. So when the elevators move, the aircraft will change their direction up and down. We have a vertical tail, a normal, which is housing rudder, which to access like this, and we have aileron on the main wing. Basically, we have got two wings. One is the main wing, and one is canards. Now it can be a little bit heavy because again we have wings, and maybe this is not needed in the glider, but for the sake of video and to can we do something? Can we win? We are testing it out. But personally, gliders aircraft only have single wing, and we are using two wings, canards and main design. But yeah, let's try this out. Aircraft such as Rafale, Eurofighters. You have seen canards, quite good looking aircraft, I guess. Now let's see very basic layout of mathematics. Hmm. So the aim is simple. If canard wing as well as our main wing is generating lift, we have to set out how much lift we want them to generate. So we want our main wing to generate nearly 70% of lift and our canard 30% of lift. As again, I'm saying maybe this is not the best design out there, but we are just checking it out. So we are thinking about fuel. Again, gliders don't have fuel. Gliders aircraft don't have fuel. They're basically, they just glide. So, but we are still talking. What if there is a fuel? What if there is a motor power glider aircraft? Okay. Hmm. Let's see. Hmm. Okay, what if we can put up a jet engine? Maybe we will check this out. That is this possible to make a jet engine thing work? Okay, we want our center of gravity to at this point, and yeah, now let's design it in a model in Blender. We are going to make a very rough design, not going to be a smooth design, very rough design. Yeah, let's make a fuselage first. Basically, we are giving fuselage. Fuselage is the place where we house the cockpit part, every other part of the aircraft. So from the front part, it is more thick compared to the rear part, but is because most of the things are going to get in the front. And we want to save weight, so we want to make the rear part as much thinner. Okay, let's do it fast. Yeah, wait. Again, it's not the perfect design. It's a very rough design. But we need to make sure that we are doing a good job, at least a good job. Okay. Hmm. 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 Okay, now it's time to make wing. We took a simple cube. I think we have to make it in aileron shapes. Basically, wings are not squares. They're in a specific called ailerons, and you are going to see how we can. Basically, air flows from the top part and from the rear part. So there is a basic the velocity of the air from bottom and top part is different. The lift force up to upper direction. Okay, so as you can see, we are giving it to a curve shape so that it may look like an aerofoil in a very rough design. Okay, so we are giving it somewhat angle of attack, angle of elevation, straight a bit. Then the bottom side find it's hard to the wing and bit more hence more. So in a way, yeah, wings have aileron shape. Sorry, airfoil shape. Okay, time to make the canard. So we will place the canard at different part and the main rear part, the vertical tail. Hmm, looks good. As you can see, there is a difference position of the canard and wing. The wings are somewhat more up direction, canard are somewhat. See, it's like hanging the more up, the better, quite stable. Fighter aircrafts have different things. Some aircraft like Mirage and Tejas, they have a lower design. The living space much lower, helps with their own agility, whatever you can say. Time to make a basic cockpit. Okay. Okay, we will simply color the cockpit in some other color so that we can signify how the cockpit looks. Okay, we will change the color afterwards, but yeah, that's the basic shape. Okay, the blue part is called the control surfaces. These are our elevators which tilt up and down so that aircraft can go up and down. Okay, we have changed the colors. It's white aircraft right now. Blue surface shows the control surfaces. These things move with motor and they are there to help us to control the aircraft. Okay, I think it's nearly complete. We have a rudder at the rear side. We have elevators. We have ailerons with us. I didn't make any wingtip, nor they are needed for right now because right now I don't want to talk about vortex. Basically, vortex are something that are created when an air will pass through it. But right now we won't talk about it. Yeah, let's make a simple landing gear, extreme simple. Uh, one at front and two bottom. But let's give it a good thick shape. Looks good. For a rough aircraft which we have made in very short duration of time, this thing looks nice and neat. Hmm. Uh, yeah. So this is the diagram, a 3D model of our aircraft which we have created to counter the competitor rider. We don't have VTAL, we have a generic vertical stabilizer with a canard wing configuration. So as you can see on your screen, my rough design, my 3D model design, both of them are not great either. But nevertheless, they are good. They are good to go. Okay. So as you can see, we have canard, we have elevators, we have cockpit, we have fuselage, we have main wing, we have control surfaces, we have ailerons, and finally a place to sit. That is cockpit. Okay, good work. Maybe next time we can give it some swept back wing design. Okay. Maybe I can see a problem. Okay. I think I made a very big problem. The position of the aircraft and the angle of the wing looks like the angle of attack is quite more. A very big angle of attack. The problem is the more you increase the angle of attack of the wing, the more lift increase, but to a certain degree, up to 15 degree. After a point, if you change the angle of attack more, and it just the airfoil goes to this shape, the lift production stop and the aircraft will come stalled. Stall means position where lift is not creating and your aircraft will just hang like this in the air without lift and without front movement. Won't be able to control your aircraft easily with your control surface. So we have to make sure. Right now we haven't made any engine like has to be pulled by another aircraft which can take it to the air. Then it can get easily. Big, humongous, not humongous. It's very large wing base. It will create a good enough lift. Okay. But again, to validate this design, we need area of wing, we need the total weight of the aircraft, and then we have to calculate. Only after then we can compare how our aircraft is compared to the enemy aircraft or the red one. Man, the red one looks far more better than again that thing took a sweet lot of time to make. Whatever. Okay, ours is going to be a bit heavy design because we are using two wings, canard and me, and we need to do some maths now. But that's for enough for today. Thank you. Bye.